Okay. Good morning, everybody. Now we are slowly actually coming to the finish line of the lecture, and before we started the last or the larger block with JavaScript and visualization of data, there is still some things left from the NoSQL databases, especially about document scores and MongoDB. So I just created a few more slides. I will update this on the website then, and today we will have two shorter breaks, just that we have some kind of structure in this. So that means after the first maybe half an hour we have a short break, and then there's a main part covering JavaScript, and then we will have another break then. So yeah, document stores is actually to store information in a kind of document-like function. So that means you have field identifiers and values. So the advantage is you don't have a strict schema. So the responsibility for keeping things structured is on the application, and this allows that you don't have to normalize the data, and you don't have to take care for referential data. So space is not an issue in this model, and consistency also not that much, but it gives you much more flexibility. And the items which you store in the database are closer to reality. So, and typically they use JSON as format. Yeah. So they actually, from the level of formal structure, they are somewhere between the relational database systems, where you have this fixed structure tables, and the key value stores, where you have no structure except that you have keys for values at all. So this is something in between. Okay. There are a lot of different out there, so CouchDB or MongoDB actually. So this is an example for the JSON format. So what is very typical, you see the thing is structured by using curly braces, and then you have here a key value pair. So that's ID would be the key, ID would be the value. And that's here on. It allows also the nesting of this key value pair. So that means a value can be another document. So that means here that's this nested document which has other keys, which limes, and then the amounts of this. You can also, we will see this then later, you can also have lists of documents, then the lists are used with brackets. So some special things in MongoDB. So every document needs a special ID that is underscore ID, and that's used by MongoDB to distinguish between the documents. It is possible to give values for this field. Then your application should make sure that they are unique, otherwise you might overwrite this. If you don't specify this field, then it's auto-generated by the database. So it's like this auto-index in relational databases. It can be anything. If you let it generate by the database, typically it's a 12-byte number, where you include the timestamp, the client machine, which contacts the server, process ID, and a counter, which is typically incremented every time you create a new ID. Okay. In contrast, or to understand the structure of a MongoDB, you should know some terms. First of all, the database. So that's a physical container for the collection, so it contains all the files, and that's very similar to this database in the relational database systems or in MySQL. So database can, or a server can serve multiple databases. Yes. In the database, we have collections. Collection is a group of MongoDB documents. This is the equivalent to a table. So it is not a table, but it's equivalent. So in the relational database, you have all these rows. The tuples here, we have the documents. So it means every collection exists only in a single database. But the advantage or the difference to a table is it does not enforce a schema. So that means not every document has to contain the same fields. Typically, of course it makes sense if you have similar structured documents, because if you want to do something, it would be good not to mix everything together. And the document itself, it's a set of key value pairs, whereas the values can be lists of values or more nested documents. Oops. So if you work with a MongoDB thing, you should design the structure according to your requirements. So there is not this very abstract theory like for relational databases. And it's also recommended to combine objects into one document if you want to use them together, because if there are disadvantages in comparison to relational databases, then that's the case that joins are not supported. So joining has to be done actually in your application, or before you insert the data in the database. There is no join command for the database. So this leads to more space consumption, but I think they say, okay, disk space is not really an issue in the MongoDB, so they take this disadvantage and buys you a lot of more flexibility. Actually, this is also then not such an issue, because it's much easier to distribute this horizontally. So the problem is if you have a relational database and the table can only be that big or as big as your disk, then if you run out of disk space, you have to either move everything to a complete different hardware, but it's not that easy to do this on the fly. Whereas for MongoDB, you just add another server and say, okay, you can can split your data between 2 servers or 3 servers or 4 servers with one master and additional nodes, and then the database does all this in the background and you don't have to take care. Actually, you can also set some kind of redundancy level that you have maybe multiple copies of the data inside, so even if one of the nodes fail, you don't have to really care, and you still can operate the system. Okay, now a few very useful commands. Of course, there are much more out there, but so that's at least to get a first idea how to use it. So very similar to MySQL, you have to select the database you want to use. It might be, if it's your own machine, you have different databases for different purposes, and so you first have to select the database. Actually, that's one of the very few cases where the database name actually appears. Otherwise, typically you don't use it in the commands. So if you don't issue a use database command, then you automatically work on the database test, and everything you do then is written to database test. If you just give then this db command, it prints out which database you are in. Actually, db then this is kind of, if you want to know what this actually means, you could think of it, it's always a reference to your current database. It's like an alias. So, or in Java, this would be something like a sys pointer. Okay, so with show DBS, you can show all the available non-empty databases. If you newly create a database and haven't inserted anything yet, this will not show up. This might be a little bit confusing. That's why I added this here, because only the databases with at least one document are shown. Okay, then once you selected the database, everything looks like this, and you can immediately insert documents. Beyond the, or above the database level, you always work on collections. So that means on certain tables. It's similar to MySQL. You cannot directly insert a tuple into a database, but you insert a tuple, or means a row, into a table, into existing table. So that's here the corresponding command. So for example, we have this collection genomes, and we want to insert a document which has only the field sequence or seq and respective value. If this collection doesn't exist yet, it's silently created, and then this is inserted into this document. Okay. So then, of course, you can drop database. So it's quite easy. So db drop database, obvious. It deletes your current database. So typically, then you always get a response object from the database. It looks like a small JSON object, which then tells dropped true or dropped 1. So that means what the system did. It's like this statement in the MySQL that many output fields or lines that always tells you if it works or not. Okay, so then inside the database you want to create collections. You need a collection name, and optional you can set various options. So the only things you really need is the name, and what can you do with the options. For example, they are set again in this key values style. So typically, like, auto indexing is true or false, so the default is false, so that means it offers auto indexing, but you can switch it off, and you have size limits. You can create capped, so-called capped collections. That means you said, okay, this collection is only allowed to keep a certain number of documents, and then you have to specify the size number. And then means if you keep on inserting documents and inserting documents, then always the oldest things are removed, and you only keep the last thing. If you don't give here an object, a document for these options, then you run with default values. Okay, and you can also drop a collection by this command. So I try to keep consistent with the, this should be actually in italic. I tried when I used fonts like this. I try to this here in fixed space. This are the things you have to type literally, and everything which is here in italic, that depends on your specific use case, on the specific name or value or whatever you can modify. Okay, so we created databases, or selected databases, created collections, and then we want to insert values or documents. There are two very similar commands. So actually the most obvious or more obvious is the insert command. Save is very similar. There is only that if ID is given and already exists in the database, then save overrides the existing document. Otherwise, it simply behaves like an insert. So that's here that's the syntax of the command. You have to say into which collection you want to insert, and then inside the parentheses you give the documents you want to insert. If you want to have a multiple insert, you have to then put here brackets around the documents. So that means here, then you put a bracket, and here, and then you can have multiple documents separated by commas. Okay, again, if you don't give this underscore ID, then it's automatically inserted by the database. Okay, a database only makes sense if you access the data. And how do you access it? Actually, typically you don't want to not only dump the database here, but you want to search for something, and that's here. For this we have the find command. So that's similar to the select command in MySQL. You can give criteria, search criteria, and fields to show, or if you leave it empty, that's like a select without a where statement, so it dumps out everything. A very useful attribute is here the pretty command. So this would be that you have here this find option, and then you add .pretty, and then this prints it out nicely formatted. Otherwise, it could happen that you just dumps out without line breaks, without offsets of the paragraph, and it's hard to read. So it's a very useful function. Okay, here are the forms of some search conditions. We have several operators, and then these options they come here in this. For example, here we have an example, and you want to find things which contain tutorials point in the field by, and then you simply have this here in the document inserted, means in the curly braces, and then here's the corresponding SQL statement. It's maybe a little bit unusual to see here the form of the other Boolean operators. So here we don't have an equals, we simply give the value for which we look, and then this $LT means lesser than equals, greater than equals. So this is the form, and then actually you say here, for example, that the likes greater than equal. So that's the form how you would phrase thing like this. Okay, you can also combine different search conditions. Then for this we use this AND operator or the OR operator, and then the conditions you want to combine are given as a list of documents. Again, you see that the style is very consistent. We need a list, so the list is denoted by the square brackets, and then inside the list again we have mini documents with curly braces, a key, a value, a comma, and so on. Okay. So we can insert data. We want to modify the data. For this we have the update command. Of course, we have to specify which document you want to update. That's the selection criteria, and the update data. So could be that we want to search for MongoDB overview documents, and then we have to use this $set, set the title to new MongoDB tutorial. So then we update this. If we want to update, typically, or the default is to update only the first document the database finds. If you want to update multiple documents in one step, then you have this parameter, have to add this parameter multi-true here after this with a comma. So that's the set operation, and then you add a comma, and then you can say multi-true. You can also use this similar to save, and then save overrides all the documents which met the selection criteria, and the update only updates the field. So again, we have an overlap here, similar to insert. Okay, remove is also quite self-explaining. Here we have to specify the deletion criteria to decide which documents to remove from the collection. So, and I think this is now the theory part. We have now this 5 minutes break, and then we continue with the demo and the JavaScript part then. Thanks. Just let me fire up this. Okay, I think before we continue, I would like to point you to two very nice tutorials. So first of all, I think that's the official tutorial from the manufacturer. So it has a get it started with MongoDB. So it explains how to some concepts of MongoDB, brief overview about the shell and so on, and then this aggregation. But also another very good thing is a tutorials point this here, where I took some things for the slides, and you see here it's actually quite very well structured, easy to understand, and so on. And if you then get yourself a MongoDB, as I show you immediately, then on the other browser, you can here actually try most of this. Here, so the things here at the bottom, replication sharding, and this is more like important in a production environment where you have to think about failure resistance and redundancy, but that's maybe interesting to know about, and so on. And then here we have even more sophisticated things. But these tutorials are quite easy to use. So here I logged into MLab, so you can get for free a database with up to 500 megabytes. So this is absolutely sufficient for testing and trying purposes. So here now you have, for example, various databases, and you can here just use this interactively, this demo 1. It gives you here the respective information if you want to log in from the command line, and so on and so on. And for example, it shows you here the collections, and if you go then here to this collection, then actually it shows you here the different I would like to increase the size. Yeah, okay, so then you can here look at the database. You see that's the beginning of the document. Here we have this ID, PubMed ID. Created is here is a sub-document. So this is a nested document with the year, month, and day fields. It has a title, and so on and so on. And that's actually, especially if you handle text data, so it's a really interesting thing, because if you look at this, you can already get an impression. If this would represent it in a relational database, it would be much more complicated to immediately find out what you are looking for. There are also a lot of aggregation functions for the okay, so let's go to small again. Okay, then we can also edit this. Oops, no, I don't want to delete this object. So then we can new search. Then you can here select several subsets or fields, or just say what do I, let's look if you have name, let's try for maybe Huber. Then okay, no results at this time. Okay, so this was just a try. After the subsets, you can also, after the search term, you can add or you can define which fields you want to have. So that means if you say, for example, field name, then :1, let's say k or true, that means show this field. If you don't show this, then it's not shown. The underscore ID field typically is shown, so you have to explicitly suppress it by saying then underscore ID equals -1 or equals 0, then it's not shown. Yeah, here means 1 include, 0 exclude. Then you can tailor your things. That's like the column selection in SQL. So here you can look at indexes if you have created one. So the underscore ID is automatically created, but you can also create for any field value an index. So index allows a very fast search in comparison to sequential iteration over the list. The index allows you also to specify if things have to be unique or to make your database unique. So that means you can apply some kind of constraints on your data if you don't want to or if you want to avoid duplications of certain values, you can set this, then that it's automatically then checked by the database. Yes. So Sparks would see that if it would save a little bit space on the disk, and TTL you can also set lifetimes for things. Then you can see here all the metrics for your different collections. I think the interesting one is number. Here you would see if you set a size limit, yeah, and that's actually that is the raw output because MongoDB always talks to you in JSON formats, but of course this is also easier to read. Okay, and then it gives also some export import helper for this. So this is actually allows you a very easy quick start if you want to get used with MongoDB. You could also do the same things directly from the command line client. So here you see they give you here the respective expressions, so you don't have to figure out actually everything on your own. Okay, so that's the web thing. The other thing is